see a function is a relation in which for each element of the domain, there corresponds exactly one element in the range. So we've kind of been seeing this already. You can't have a repeating x and have a function. If x repeats, it's not a function. It's still a relation, but not a special one, the function. So look at number 1. It says determine if these are functions by looking at ordered pairs. So on example 1, we have a point 1, comma 2, a point 3, 4, 5, 6, and so on. So you just look through. Remember I told you to use braces. That means these are items in a set, and there's just those 3 points, for example. So none of the x's repeat, so you say yes, it's a function. If there's no x repeat, you say yes, it's a function. In example 2, you have a 1 with 1, and a 1 with 2, and even a 1 with 3. So definitely not a function. 1 is repeating with multiple y values, not a function. Notice on example 3 that the y repeats. You have 1 with 3 and 5 with 3. That is okay. So make yourself a good note. That is okay. If the y value repeats, it's still a function. It's not a one-to-one function, which we'll study later, but it is a regular function that we're studying now. Okay, so that one's okay. So no, if the x is repeated, this contradicts the definition of a function. You would have one element of the domain corresponding to more than one element of the range. For example, the 1 with 1 and 1 with 2. Okay, here's the way we use it if we have a graph by the vertical line test. If you can just look at the picture and there's no vertical repeats, we say that's a function. So in your example 1, you have a curvy graph like so, and that is a function. The vertical line only hits it once. Whereas example 2 has a sideways parabola, which is not a function because the vertical line would hit it more than once. And then the next one is by equations. And that can be the trickiest way to figure out, especially if they're equations we're not familiar with. You may just have to explore the function, or not a function, explore the equation and ask yourself, is there anything I can plug in to this for x and y that causes the x to repeat? And in general, this happens anytime y is to an even power. X equals y squared, or x equals y to any even power is not going to be a function because there are two different y values that give you the same output for x. If you plug in y is 2, 2 squared is x is 4. Plugging in negative 2 for y gives you x is 4. So the x repeats. There's one x value that has 2 different y values, so not a function. It also happens if y is in absolute value signs, like example 5 on the next page. In general, it happens when you mess with the y variable. If you make the y to an even power and absolute value signs, those are absolutely going to cause the repeated x. Also, it happens in example 8 if it's actually just a vertical line. Do you recall that x equals a constant? That is a vertical line at 7. So that would be a no as well. So x equals a constant is a vertical line itself, so the vertical line test over it would absolutely fail. Also, if you have an inequality symbol, inequality means you have multiple x values that correspond to y. So inequalities have a whole region of solutions. So inequalities are not functions. All right. I'm going to go ahead and flip over to the page where you have increasing, decreasing, and constant functions. Make sure I get through this. Okay, increasing, decreasing functions. Increasing means you have a positive slope on that portion of the graph. Decreasing is a negative slope. And then constant is a zero slope. Which reminds me, if you looked at your homework yet, there's a question that says, is this a constant function? A constant function means you have a flat line, a horizontal line, not like this vertical. X equals is a vertical line. It has an undefined slope. Okay, a vertical line, the slope is determined by the rise over run. If you figure out the rise, however much that is, it's over the run, which there's no run, so it would be divided by 0, so it's just undefined, that slope is. But a constant slope is a 0 slope, like a y equals a constant. Y equals, let's say, 2 is a horizontal line at 2. So that's what we consider a 0 slope, or a constant slope. Okay, a decreasing slope is a negative slant from left to right, it's going downhill. And then an increasing or a positive slope, when you read your graph from left to right, it's going uphill. So you may have a question in your homework that has a picture like this. I didn't get it into your notes, but say you had a picture like this. That's a piecewise graph. It's got 3 different sections. And it says list the part of the function that is decreasing, the part that's increasing, and the part that's constant. So this is a negative slope, a negative slant. Right? So that's the decreasing part, and you list it in reference to the x values, or the domain values. So let's say that point is -2 and that point is at +4. So we would say it's decreasing from -infinity and then stops at -2, like that. Then it's constant or flat line, and it's sharing that point, so we can use a bracket for both of these. Then it's, so that's decreasing. Then it's constant from -2 over to 4. And then it starts being positive or increasing at 4. 4 onto infinity. And then the next concept on 2-3 is the concept